Looking for a cleaner way to write conditional logic in C#? Learn how to use pattern matching for more expressive and readable code. Pattern matching in C# allows you to test an object structure or type in a simple, readable way, improving the clarity of conditional logic. Let's start with pattern matching using the is keyword to check types and extract values. Here we check if data is an integer, and if it is, we extract the value into number. Pattern matching also works great in switch expressions, making them cleaner and more powerful. In this example, we use pattern matching in a switch expression to identify the shape and extract its properties. Let's take it further with property patterns and positional patterns for complex objects. Here we match the properties of an object and extract them in one line. Pattern matching in C# simplifies conditional logic and makes your code more expressive. Use it to write cleaner, more readable code. Need to work with dates and times in your C# applications? Learn how to use the powerful datetime structure to handle all your date and time needs. Let's start by creating a datetime object representing the current date and time. You can use datetime now to get the current system date and time. Next, let's format the datetime object into a more readable string format. You can format dates and times in various ways using standard or custom format strings. Now, let's see how to convert a string into a datetime object using datetime parse. With datetime parse, you can convert a date string into a datetime object. Datetime also allows you to perform arithmetic operations like adding or subtracting days, months, or years. You can easily add or subtract days, months, or years from a datetime object using addDays, addMonths, or addYears. Using datetime in C# gives you powerful tools for handling dates and times in your applications. Make sure to use these techniques to format, parse, and manipulate date and time data with ease. Need to calculate time intervals or manipulate dates in C#? Learn how to use timespan and datetime to perform powerful date and time calculations. Timespan represents a time interval or duration like hours, minutes, or days, making it useful for performing calculations with time. Let's create a timespan object that represents a duration of 2 hours, 30 minutes, and 15 seconds. You can specify hours, minutes, and seconds directly when creating a timespan. Now, let's manipulate datetime by adding and subtracting a timespan. Here, we added and subtracted a timespan to calculate future and past times. Timespan is also useful for finding the difference between two datetime objects. In this example, we calculate the number of days between two dates using the total days property of timespan. Timespan and datetime manipulation in C# gives you flexibility for handling time intervals and date calculations. Use them to make your date and time logic more powerful. Want to simplify your code and make it more readable? Learn how to use enums in C# to define a set of named constants. An enum in C# is a way to define a set of named constants, improving code clarity by replacing magic numbers with meaningful names. Let's create an enum representing different user roles in a system. Here we define user role with 4 possible values: admin, moderator, user, and guest. Now let's use this enum in a method that checks user permission. This method checks the user role and prints whether access is granted or denied. Enums are backed by integers, so you can convert between enum values and their underlying integers. Here we convert userRole admin to its underlying integer value and back from an integer to an enum value. Enums in C# improve code readability and are a great way to represent a set of related constants. Use them to make your code more meaningful and less error-prone. Curious about value types in C#? In this video, we'll learn about structs, an important C# feature for defining lightweight data structures. A struct in C# is a value type, meaning it holds data directly rather than referencing it like classes. Structs are useful for small, immutable data structures. Let's create a struct representing a 2D point on a grid. Here, we define a point struct with 2 fields, x and y, and a constructor to initialize them. Now, let's create and use an instance of our point struct. Unlike classes, structs are stored on the stack and are passed by value, meaning each copy of a struct is independent. Structs differ from classes in several ways. Structs are value types stored on the stack and are usually used for small, lightweight objects. Classes are reference types stored on the heap and better suited for more complex objects. As you can see, when we copy a struct, the original value remains unchanged. Structs are great for representing small, simple data types where performance is critical. Use them wisely to improve the efficiency of your C# applications. Want to add new functionality to existing classes in C# without modifying them? In this video, we'll learn about extension methods and how they can make your code more flexible. An extension method allows you to add new methods to existing types without altering their source code. It's a great way to extend functionality while keeping your code organized. Let's create an extension method to reverse a string. Extension methods are defined as static methods in a static class, with the keyword this preceding the type you want to extend. Here we define an extension method reverse a string for the string type. Now we can call our extension method as if it's a method of the string class. As you can see, the reverse a string method is now available on any string instance, just like a built-in method. Extension methods can be especially useful for simplifying complex logic. Let's say we want to add an extension method to the int type that checks if a number is even. This method adds new functionality to the int type without modifying it. Extension methods are a powerful way to extend existing types without inheritance or modification. Use them to keep your code clean and reusable. Want to write more flexible and type-safe code in C#? Learn about generics and how they can help you create reusable components. Generics allow you to define classes, methods, and interfaces with placeholders for the data types they operate on. This means you can create code that works with any data type while ensuring type safety. Let's create a generic class for a simple container that can hold any type of data. Here, T is a placeholder for the data type. We can create a box instance for different types, like int or string. Now, let's define a generic method that swaps two elements in an array. This method works with any data type, making it very flexible and reusable. Generics are commonly used in collections like list or dictionary, where you need to handle data of various types while maintaining type safety. Using generics with collections ensures that only the specified data type can be stored, reducing runtime errors. Generics in C# help you write more versatile and type-safe code. Use them to create reusable components that can work with any data type while maintaining type safety.